Section 7.2, Simplifying Radical Expressions. Remember from the last section that the index is the denominator of the exponent, and the exponent here is the numerator. So we can rewrite this as the radicand to the power of 4/8. Then reduce that fraction, and we get x to the power of 1/2. And turn it back into radical form. An exponent of 1/2 is a square root of x. Another example, if we have square root of x times the fourth root of x. We cannot multiply these because the indexes are different. So we rewrite each into its exponential form. The square root of x is written as x to the power of 1/2. And the fourth root of x is written as x to the power of 1/4. Now we can multiply our variables, and when you do so, you add the numerators. X to the power of 1/2 plus 1/4 is x to the power of 3/4. Now we can rewrite x in radical form as the fourth root of x to the third power. The power rule of radicals. If your index is exactly the same, we can multiply our radicands. So this gives us the nth root of a times b. For example, the square root of 3 times the square root of 2 equals the square root of 6, because 3 times 2 is 6. And the fourth root of 64 and the second power times the fourth root of 2n equals the fourth root of 64 times 2 is 128, and n squared times n to the first power is n to the third power. Simplify giving exact answers. Exact answers mean we're going to leave the radical sign in our answer. If we were simply to take our calculator and take the square root of 32, we would get a decimal answer. That is an approximate answer. An exact answer leaves the radical sign in place. So to do that on the square root of 32, because it doesn't give us a whole number, we must factor the 32 so that one of those factors is a perfect square. And that would be 16 times 2. 16 times 2 is 32, and 16 is a perfect square. We can take the square root of it. And that gives us the square root of 16 is 4. That comes on the outside of the radical, leaving the 2 underneath the radical sign. Another example would be the cubed root of 54. If I take the cubed root of 54 with my calculator, I will get a decimal number. So I must factor the 54 so that one of those factors is a perfect cube, and that would be 27 times 2. Cubed root of 27 is 3, so that comes on the outside of the radical sign, leaving the 2 underneath. One more example, the cubed root of 40 x to the third y to the fourth. We can factor our constant, or our coefficient I should say, but we can also factor our variables. To factor 40 so that one of those factors is a perfect cube would give us 8 times 5, because 8 is a perfect cube and 8 times 5 is 40. X to the third power is already a perfect cube. But y to the fourth power, we want to go down one less number so that it is divisible by the indexes, kind of a shortcut. So that would give us y to the third power times y to the first power. Now we can take the cubed root of 8, which is 2, and that comes outside, leaving the 5 underneath the radical sign. The cubed root of x is x, that comes outside, so that's gone. And the cubed root of y to the third power is just y, so that comes outside, leaving the remaining y underneath the radical sign. The quotient rule of radicals. As long as your index is exactly the same and the radicands are different, we can change that to one single radical with the fraction underneath and reduce if possible. For example, the square root of 15x over the square root of 3. They're both the square root, so we can write that as the square root of 15x over 3, and now reduce our fraction. And that gives us the square root of x.